Hi, so my name is Aaron, and I'm just going to talk to question 2A to D of our tutorial sheet 3 for control. So for question 2A, we have GS is equal to 10 over S plus 5. So this can be simplified into 10 over S over 5 plus 1, which is then equal to 10 over 5 multiplied by 1 over S over 5 plus 1, which then simplifies into 2 multiplied into 1 over S over 5 plus 1. So from this we have no zero poles because we have no S on the top. However, we do have a constant 2 outside, and we have a pole of -5 from our initial question. So when we use our log formula to get our decibels, we use 20 log to the base 10 of 2, which is our constant, which gives us a 6 dB, and then our pole is at 5 radians per second. So from our phase, so for our phase we have 0 degrees up until 1/10 of the pole. Then it drops linearly to -90 degrees to 10 times the to 10 times the pole. So if we look at the graph which I plotted out here, for the magnitude we get that 6 dB, and then it gradually falls off at -20 decibels per decade. So from our pole and our phase, we can see we come across to 1/10 of our phase, and then it drops off linearly until we get to 10 times our phase, and then it begins to level out. So that's question 1A. So question 2B. So for question 2B, we actually have a second order system. The way we can identify a second order system is we have an S squared. So for the second order system, we need to find our poles. So to find our poles, we have to use the -b formula. So I've completed out the -b formula, and I've got 1 over 2 is equal, or 1 over S is equal to 1 over 2 by -5 minus the square root of 21, and also 1 over 2 plus the square root of 21 minus 5, and we have no zero poles. So we just look at the graph for this, and we have so for our magnitude we have +40, and it comes across and then it falls off at 40 dBs per decade. So it falls twice as fast as the first order system. And from our frequency we can see it comes across and it comes down, and it comes down to 180 degrees, so it does a full half phase or full phase shift. So that's our question 1 and question A and B done. So let's one of the question. So we've question 2C. So question 2C, we now have this S on the top. So what we do now is we take out the 20 that's in front of the S, and we take out the 2 that's on the bottom. So we now have 20 over 2 multiplied by S over S over 2 plus 1. So we have 0 pole on top, and we have 0, 0, and we have a pole of -2. So if you look at this on the graph, we go from -40 dBs up at gaining 20 dBs per decade, so until we get to this 20 point, and then it begins to level off at the top. and then for our phase we come across at 80 until we hit this 10 to the minus 1, and then it falls off and down and around to the 0 point. So it completes from the 90 degrees phase down to 0, so it's a 90 degrees phase shift. And then for question 2D, we go back to our second order system. So we have this s squared again, so it goes 30 over s squared plus 4s plus 3. So we factor out and get s plus 3 and s plus 1. So we've poles that s is equal to minus 3 and s is equal to minus 1. So because this is a second order system, we're going to be falling at that 40 dB per decade again. So looking at this graph, this is our magnitude. So we start off at 30 dBs and we come across, and then we start to fall at this 40 dBs per decade and down. And then our phase shift is going to be 180 degrees. So we're at 0 initially, then we hit the point of 1 over 10 of the pole. So we come down and we're down at a full phase shift round to minus 180 degrees.